Do we remember this? What is this used for? Good, arithmetic sequences. What is the definition of an arithmetic sequence? Yes, I need you to use better language though. I need you to use different language. Use mathematical language. No, very much the wrong word. That's for the other type. Stop using same. Or use a mathematical word for what's happening. Oh my goodness, stop saying, what's the mathematical word for decreasing and increasing? Adding and subtracting, okay? Yeah, okay. So this means we're going up by a consistent number or we're going down by a consistent number. We're adding or subtracting the same thing each time, right? So you're right that it's also linear. This is definitely a linear equation. All right. What about this? Okay, this is geometric. Okay, it doesn't add and subtract. What's it doing? It's multiplying or dividing, but we don't normally say it's dividing those. So if I'm timesing by, right, so I could be timesing by 2, I could be timesing by half, which is the same as dividing by 2. So we're always talking about multiplication. So we need to remember what these two are. Now, annoyingly, the book is going to start changing what letter they use. It's exactly the same thing though. Instead of A, we're going to start using U. It doesn't make a difference. It's exactly the same thing. But when you get to an arithmetic sequence, it's going to be asking for U of N. Okay, is going to be the first term plus the difference. Oops, sorry. And actually, sometimes it's going to use N and sometimes it's going to use R. It doesn't matter. It doesn't mean a different thing. They're just using a different letter, okay? So if you see N or R, they're interchangeable. I'm not really that fussed about which one you would use on a test, but you should use whatever the question's using. If the question doesn't specify, you can use N or R, but if the question uses one of these letters, please follow suit. Make sense? All right, I'm just going to get my book out, remind myself what I have to tell you. All right. So there's something I want to talk about that we did look at last year, but we didn't go into too much. So this is an algebraic rule, right? This is going to help you find the 87th term without having to count up to the 87th term, right? That's why we use these. They help us skip things. Does anyone remember what it's called when you can't do that, when you just have to know the previous one to get to the next one? Do we remember what that's called? Kind of. Kind of recursive. Okay, so a recursive rule means that we must know the previous rule to get the next term. Sorry, we must know the previous term to get the next term, which is kind of annoying because if we want the 62nd term, we're going to have to count up 62 terms, right? So we don't like doing that, but sometimes we're going to be given a rule like this, and we won't be asked to find the 200th term if they're going to give us something like this, but we need to know how to use it. I think we only did 1 or 2 questions with it like that last year. So if I say U of N, that's just going to be whatever term it is. But I can also say, if I said U of N is like 4, what I might be able to say is U of N plus 1. So that is the next term, right? So whichever term this is the one after that. Make sense? All right, I'm just adding one to it. Then I can have plus 2. That's the one after this, right? So all I'm doing is I'm using recursive language. You can also use the word recurrence. So recursive recurrence, it's the same idea. So if the rule, so let's say that the next term was 10, What could be going on between here? Okay, we could be adding 6. Is that the only possibility? Okay, we could be timesing by 2 and then adding 2. The point is we don't have enough information to figure it out. Okay, how many terms is minimum for finding a rule? 3, right? So if I then told you that this was 16, then we could say, well, it's got to be that now. But if it was times 2 plus 2, this would be a different number. So you must have three terms to determine a rule. Sometimes they will give you more information. So let's look at one of these recursive rules. Actually, no, first, okay. So, remember we talked about the nth term. If I ask you for the nth term, what am I asking for? I'm asking for the equation, right? I'm asking for the rule, the algebraic rule. The way this book is going to ask you for that same thing is to ask for the general term. So if you're ever asked for the general term, this is what you're being asked for. The general rule of how you get any term, okay? So just some slightly different language, but it's all the same thing. All right, grab your pen and paper out. I'm going to ask you to do something for me. So I'm going to say the nth term is, I'm going to give you a complicated looking thing, and I'm going to ask you to find me the first 3 terms. So I want the first 3 terms and the 8th term. Okay, I'm going to give you a second to do that. This is going to be term number, so U of 1, U2, U3, and U8. So if you can find those 4 terms for me, we'll make sure that we're doing it right. So if there's no sign, what are they doing? Yeah. So if there's no sign, they're multiplying each other. All right, have a go at doing that. Shouldn't need a calculator for any of this. There's no way you should need a calculator for any of these. So we've had a lot of practice doing normal algebraic rules, but not writing recursive rules. So we'll also have a go at doing that. All right, have we done that? All right, so first term, so that means I've got -1 to the power of 1 times 1 over 1 plus 3. What's -1 to the power of 1? -1, what's 1 over 1 plus 3? 1/4 or 1/4, so what's my answer? Okay, don't change it to decimals. We're working in fractions, we're staying in fractions. If the question is in decimals, you can do decimals, but if the question is in fractions, we're staying in fractions. All right, so this time it's squared, and then whoops, and we've got 2 over 2 plus 3. So then this is what? It's just 1, so that's positive, so then we just get 2/5. All right, what's this one going to be? Let's not do it all. Negative what? Half, right? Because this is going to be 3 and then 3 plus 3. So then 3 over 6. So -half. And then this one. So this is going to be back to being positive. 8 over what? 8 over 11. All right. So this now, if I gave you these as a thing and said, come up with the rule, that would be ludicrous, right? They're not going to give you ones like that in reverse. They're going to make you find the first few terms rather than ask you to work backwards for something that difficult. All right, let's do a recursive rule now. So if I give you a recursive rule, you need to be able to move up, and you're not really going to be able to find the rule as such.